Welcome to the AMSE Science Report. I'm Alan Lowe, Executive Director of the American Museum of Science and Energy and the Atomic History Campus at K25, both located in Oak Ridge, Tennessee. Did you know that if you put all the microbes in the world together, all the bacteria, viruses, protozoa, and archaea, their combined mass would be over 1,000 times that of all humans put together. They're everywhere, including in our bodies, where they've established symbiotic families of microbes or microbiomes. To learn more, I spoke on our podcast AMSECast with Robert Hettich, leader of the Bioanalytical Mass Spectrometry Group at Oak Ridge National Laboratory and a joint faculty member in the Microbiology Department at the University of Tennessee. Bob is a leader in the field of microbiomes and the founder of a field called metaproteomics. I first asked Bob to define a biome.
Microbes, clearly there are viruses and bacteria and archaea and a whole range of things that are microscopic. Microbiome really describes the community of members that live together. And so microbiome is a collection of these members that are living in some relationship, and that's called symbiotic relationships. And so oftentimes these are adjusted in a system, and these can be in the ocean, they can be in mud puddles, they can be in the rhizosphere of plant roots. It's a community of microbes that live together that basically infer some function.
Our gut microbiome is vitally important to our health. Here's Bob.
The bacteria in our gut do way more than just exist because they happen to be opportunistic and be there. They're actually helping to train your immune system. They're helping to fight out pathogens. They're also very essential for contributing some enzymes that our human body doesn't have. For example, bacteria do a good job of degrading plant polysaccharides, whereas human systems don't have the enzymes to do that. So if we didn't have bacteria in our gut, there wouldn't be much point in eating salad. So they exist in we call a symbiotic relationship. So they feed the host give them something in return, and it's a very stable thing. If you don't have bacteria in your gut, you're going to be in trouble with a lot of disease cases, and that is manifest in a variety of situations.
Advances are coming that will customize our ability to supplement our gut microbiome, though Bob warns we must proceed carefully.
What I think is appearing on the horizon as we learn more in the science of this field are customized probiotics, and that's really exciting. So if you could go to your doctor and you could say, well, I'm deficient in this type of bacteria that's beneficial, and design a customized probiotic that could basically move you back toward health. And this impacts all sorts of things from obesity to inflammatory bowel disease or whatever. The customized probiotics are also a bit dangerous too, because we don't know what we're doing and we introduce something. It's a very complicated system. You can knock it out of whack. So I think we need to learn a little bit more before we dive too deeply into that.
Bob is a founder and an international leader in a field called metaproteomics.
So meta means the whole system. So we want to look at all the genes in the system, which is like kind of the cookbook. That's sort of the blueprint of it. The problem is the cookbook isn't the cake. So we want to move from the genome space down to the functional space, and that's the realm of metaproteomics. So instead of looking at all the genes that are present in your microbiome, let's look at all the proteins that are there. And the proteins will tell you the functionality, how hydrogen is disposed, what enzymes are active. And so the genome is very static. That means that, basically the genes that are there are pretty representative and they don't really change. The proteome is very dynamic, and the proteome is very susceptible to antibiotics or a diet change or a lifestyle change. And so by measuring the proteome, you can measure the dynamics that could be related to the difference between disease and health. So it's like a little more fine-tuned window into this. So metaproteomics really relies on mass spectrometry. That's the field I'm in, my training in analytical chemistry. So mass spectrometers are a really good way of measuring these proteins from very complex mixtures. That's kind of the essential aspect.
The gut microbiome is another example of the incredible complexity of our bodies, with every part, including these tiny microbes, working to keep us moving each and every day. Thanks for listening. For more information, please go to amse.org.